Good morning, everyone, and let's get started. Welcome to this morning webinar about ArcGIS Enterprise performance and load testing. This webinar is a part of free series hosted by Eagle Technology, the official Azure distributor for New Zealand and South Pacific. This is continuation of this series that we are continuing in this year, and throughout the year, we look at the different topics such as deep learning, agriculture, ArcGIS Enterprise, desktop, and others. My name is Zorko Sostrik, and I'll be one of the co-hosts for today's webinar. I'm a part of support group, and we are involved in technical support and webinars and training similar to this one. Today with me, I have Julian Inskip, and he will give you a brief introduction. Julian?
Good morning, everyone. Yes, I'm Julian Inskip. I'm a solutions architect here with Eagle Technologies, working out of the Auckland office.
Thank you, Julian. What we're going to talk about today? Today we're going to talk about how we do performance testing. So we're going to talk about what, why of performance testing, the reasoning, and we're going to describe some of the tools that are available for doing so. But before we get to that, let's talk a little bit about using the webinar client if you haven't used it yet. If you have a question that you would like to ask, you can use the panel, and on the right-hand side at the bottom, there is option to pose the questions. We will do our best to answer your questions at the end of the webinar. There's a dedicated questions and answer session at the end of the webinar. Now let's talk a little bit about how and what we can do. After ArcGIS Enterprise is deployed, administrators can think about getting the information about performance of services under current conditions. ArcGIS Server Manager log section in particular provides statistics we can utilize to evaluate service performance. There is a set of basic statistics available, and we already see some of these statistics displayed in here. When we are looking at one of these statistics, we can include one of these parameters, either total requests, average response time in the seconds, maximum response time, timeouts, or service maximum running instances. So it's pretty simple type of statistics where we can do how system did perform in the past. So that was coming from statistics that was already collected. If we need to, we can change the default for these statistics, and that is done on a server admin directory. The settings that we can do include enabling or disabling generation of statistics. And by default, the statistics that we are collecting are aggregated every 30 minutes. Sometimes it may not be most appropriate, but we can change it to whatever period we deem is appropriate. Also, the statistic that is collected is kept for forever by default, but if needed, again, we can change it to any number, and that will be the number of days that we are keeping these statistics for. So this is what comes out of the box with our ArcGIS Enterprise, more specifically ArcGIS Server. But there are some other tools that we can utilize to give us maybe a little bit more information. One of these tools is System Log Parser. That is a free tool. Of course, there are paid tools as well. And the System Log Parser has an option of using graphical user interface or command line, and that is great flexibility because it can be scripted and automated. Some of the options in the log parser include monitoring of ArcGIS server as a web or a file system, looking at IIS or the load balancer. So it's looking at the log files, and then we can actually produce a report. That report is provided as Excel spreadsheet. That spreadsheet has a number of worksheets, and these worksheets includes a summary. So you're just going to see it as a collection of sample data. So we have this summary information. We also have capabilities. Again, I'm just showing a minor part of that worksheets that you see in here. Wait time. We can look at the instance creation time. We can look at the arrival rate for these. Users, what we had in terms of users that were using the system, and finally request throughput. So all these things are collected from the logs, and these are details about the current environment, how it did perform. To tell us more about performance testing, I'll hand it over to Julian. So let me make Julian presenter.
Great, thanks very much for that, Zorka. Yes, I would like to just start off with a two quick polls. Let me just launch that. So just finding out if anyone having a look at some of those tools now, if anyone is actually performing any of these sort of tests. You should be seeing a couple of answers there. If you can just submit your vote over there, and we can have a look at some of the responses coming through. Great. I'll just leave it open for a few more seconds here. And then I'll just share those results here. So yes, it looks as though some of you are actually performing some tests and some not. So hopefully after this webinar, we'll give you a couple of ideas on how you can go about performing some of these tests. Great. So then moving on. So what is performance testing? So under the blanket of performance testing is there's two main sections of this, and that would be a load test and a stress test. What a load test is, a set number of concurrent threads that you are testing against your service. And by thread, I basically mean a request going through to your service. These set number of threads will represent very loosely how many users are accessing your service. So you'll be representing your number of users. A stress test is a bit more than that, where you are now testing the actual upper limits of what your system is able to perform. This should be done with great caution because there are, you are putting a large stress on your services, sorry, and that could cause some issues with your actual system. Also important to note that these sort of tests should be done outside of your normal working hours, just so that you're not interrupting any of your users on your system. Also, I'd just like to highlight in the master agreement, there is a section under the prohibited uses to not do these sort of tests in the Esri cloud services. And with this, they're referencing to ArcGIS Online. So these sort of tests are meant for your internal ArcGIS Enterprise environment. Some terminologies and definitions that I'll be going through with some of the examples here. As you can see, requests, this is basically every request coming through to your server. And it's the smallest unit of work being performed. If I go into the actual help over here, which is on the Esri site, you'll see we are testing the URL and using the export function for that. Attached to that will be a number of requests. Here we've got the bounding boxes, spatial references. So all of these, and this will become a bit clearer when we're actually looking at the actual application, the JMeter application, and bringing in things like your resolution, transparencies, and so on. A transaction is referring to either a group or one of these requests. In this case, we are representing one request per call there. A thread is just the mechanism for testing and requesting your transactions to your server. Response time, this is how long the actual server will take to respond to that request coming through. The throughput, this is the amount of information that will be passed through the system, and it is represented by requests per second. And a bottleneck, this will be something that could be causing poor performance for your response times. Things like detailed labelings or incorrect queries could cause an issue. Also showing detailed features at a small scale. So when you zoomed out, showing a lot of features, all that can cause an impact on your actual service performance. Always a good thing to initially set up a bit of a strategy on how you're going to be performing your load tests. This will, you'll need to answer questions, things like, is this going to be a load test or a stress test? What sort of outputs are you expecting from these tests that you're going to be performing? The current service performance, this is just really a manual check to see how your service will be performing, just by adding your service into a web map and zooming in and out and panning around, just to get an initial feel for how your actual service is performing. Coordinate your test execution. This will determine how often you're going to be running your tests. Are you going to be doing it monthly, every 6 months, or perhaps annually is enough for these kind of tests? Also setting up what time of the day you're going to be running these tests at. As I mentioned before, you want to be running this outside your normal working hours, so you not impacting any of your existing users. Estimate usage pattern. You could have, say, 2,000 staff members in your organization, of which perhaps only 150 users will be accessing your applications during your day. And even only on a sort of 10 to 20 minute period, could only be looking at 20 concurrent users on your system at the time. So it's important to understand how your applications will be used, and just to document that, which will then help identify how you will be performing these tests. Your ramp-up threads, perhaps start with your initial run of only maybe one thread, and then slowly increase that to 5 and maybe up to 20 or 30 threads for your load test. Your test duration and location. Around the test duration, you obviously don't want to run this kind of test for 24 hours. So anywhere between a sort of 5 to 20 minute window should give you a good enough representation of these usages. And regarding the location, it's also important to see where you're going to be running these tests, because if you're running it on the actual ArcGIS server, it will perform a lot quicker than, say, on your internal network or even across the internet for your public services. Even for that, looking at your actual line speeds could have an impact. Sort of a 10 meg line would obviously perform much differently to an 800 meg line, for example. Your ArcGIS server log levels also play an important role. When you're running them as verbose or debug log levels, these could have a minor impact on your service performance. It's just important to note that there could be a performance impact on that. So always good to run those at slightly higher levels than that. Then on the results the results are about the throughput of your tests, and this closely resembles your users. However, it's not exactly the same as your users. Your users kind of have different patterns to how this test is actually been running in terms of wait times, varied, and so on. There are ways to try and replicate that as close as possible. So it could give you a representative result for those. Going on some of the available tests, Zorka has covered some of those. So in your developer tools, you have an option to identify what sort of services are being accessed and gives you a kind of indication of those response times in there. There's another application called Fiddler, which also is for your network, incoming and outgoing network traffic, for monitoring that. As Zorka has mentioned before, there's the ArcGIS logs and statistics that you can investigate and get some stats on that, as well as the system log parser, which uses your ArcGIS server logs to get some patterns on that. On the desktop side, on the ArcGIS Pro side, there's an add-on called Perf Tools, and this is a good way to also see how your actual data and that is performing, and this is very useful to check possibly even before you publish your service. It'll kind of identify any possible bottlenecks between your client and your actual server. There's also the performance assessment tools, affectionately known as PAT. This is a set of those tests in a sort of controlled manner, and very useful for benchmarking your ArcGIS Pro performance on your actual machine also. And then you have the Apache JMeter, which is really our go-to tool of choice here for performance testing, and we use it quite a bit. And this is primarily what I'll be showing from here on out. So what is JMeter? It's an open source Java application that pretty much runs on most of the operating systems, on Windows, Linux, and your Mac OS operating systems, used for performance load testing and your stress testing, as I mentioned before. So we use this extensively for those types of tests. You've also got the option of a user interface as well as a command line option, and that's used for your automation of these tests that you can set up, and also many enterprise level kind of features that are available for your tests. How does JMeter actually perform these tests? So you will initially set up a test plan in JMeter, which closely replicates the usage of your service. It creates the requests and sends it to your target server. In this case, the ArcGIS server services. The ArcGIS server will then respond to that and then send those requests back to JMeter, where JMeter will then save those responses. It'll collect all of that data for statistical information, and then all those statistics are then used in an output report that you can view and analyze. Some links around actual JMeter on how to download it. There's the link over there. It's just a zip file that you will unzip into a directory and then run from an actual batch file that will open up that Java application. There's also a very detailed component reference over here that has a list of all the components that are available in JMeter that you are able to test with. We'll be getting into some of these listeners, some assertions for error testing, and some other options. So you will start off with a thread group over here. And we'll get into that pretty shortly here. So this is the interface of JMeter. You've got a couple of tools around the top over here for running your actual test plan, stopping it during a test, for clearing any of the results, as well as some search and help options. Here is an example of quite a detailed test plan that's been set up where we're testing each individual scale level to represent zooming in and out. You're able to import a CSV file with all your configurations, which can then be used for variables throughout all of your test plans over here. This is an example of that configuration file where we've got our bounding boxes, we're using a scale, the actual service that we're testing, as well as tokens for your secure services, and then the actual function that we'll be using, which replicates how an application or your web map calls those services. You also set up an HTTP request, and here you can see some of those variables coming through from that CSV, as well as a number of parameters that you set up for your URL tests. So with that, I will go into a bit of a demonstration, live demonstration here. This is the unzipped directory of the actual application. To run it, you'll go in and run your JMeter file there. So I have one open already, and I've just started adding some of these. To add some of these components, you'll right-click on your application or on this component here, and depending on which component it is, depends on which options are here. Starting off is setting up your thread group, which is set up here, and I've got the number of threads, and they reference it as a user. in the strictest sense, as I mentioned, it's not quite the same, but does replicate more or less a user. Then you've got your ramp up period in seconds. This would be how long it takes to actually ramp up to your number of threads over here. And then how many times it will go over and run that. And setting a duration over here of not going over, in this case, only 1 minute, just for testing purposes here. But that you would set up to be your 10 or 20 minute period, and infinite loops you would enable here. I've also set up a configuration element here, which is a CSV file. I'm just bringing in a simple CSV file and setting all the column names to be the actual variable. So this is the actual CSV file that I'm going to be running the test on here. You'll notice over here, I've just got a couple of incorrect tokens over here because I just want to show how the errors are actually handled. From here, you also add in your samplers, your HTTP requests. In this case, we're using the secure protocols and pulling in, as shown in previously, some of the variables. This would be the actual service we're testing and some of the parameters coming through, where I'm bringing in the scale and also the token from those variables, as well as our bounding box. So some other items that we need to just add in here, and I'll show how to add those, is some listeners. So just to identify as the test goes, we want to kind of see in real time what sort of responses we're getting. So I've got a graph here. I'll just set the intervals to 1 second intervals. And I'm also going to add a view results tree here. So every time a request is sent, it gets returned here, so you can actually see what's being tested. Once that is up, just need to save that before running. So that's run through, and now you can see every time it's testing, sending through a request. This is the actual URL that's built up through my configurations over here that's being tested. And also we're getting the actual response that the server is sending back. You'll notice for those first ones with an incorrect token, although it's showing that it is running correctly and returning a valid result, the actual URL is correct. However, the URL is referencing an actual error that's coming back. So you are able to actually catch all of these type of errors, and that is through an assertion over here. In this case, I'm just going to do in the text response what's coming back, anything that contains, and it's just the inverse of that, and anything that contains that actual error coming through. And I'll just say, yeah, you have an incorrect token as an example. So this would be the actual custom message coming back. So I'm just going to clear those results, and as I run that now, you'll see the ones with the incorrect token will actually return an actual error now for those. So you can set up your custom errors coming through in that way. Just showing an output of one of the CSVs from that. You've got your timestamps when you ran it. Just going through, you've got some errors over here, which are other errors. Your 500 error is, oops, sorry. your 500 error is pretty much showing that the server wasn't able to respond, which means that it's too busy to respond for that. Together with some of the responses coming through and values actually being returned. These are actually also used in the HTML report that we'll get into a little later. It also returns the actual full URL that's being tested. So that's a bit of an overview of the JMeter and the actual user interface. So there's also an option for the command line interface where you can run it and automate this through batch files and run that through scheduled tasks or similar options. When you request the JMeter and send through the --, it will print out all of the help options over here and parameters for using the command line tool. So you will have a very detailed description of what options there are. Alternatively, you could go to that help online website that has all of the components also. Here is an example of one of those requests that have been set up in command line, where here we're calling the JMeter. We then enter the -n parameter, which means that we're running in the non-GUI environment, and a couple of other parameters through here, bringing in your actual JMeter configuration file here, your output CSV files, as well as options for the dashboards. So when you run it in command line, these are some of the results that come through. So each of these gets returned at certain time intervals. So you can just monitor the progress of your actual test and how that's being performed, while returning some of your response times here, as well as any errors coming through and how many active threads are being tested. And this is an example of one of those, as I showed before. So getting into the actual reports that are generated, as mentioned, using the -e and -o parameters for generating that, and then your output folder. Straight off, you can see a bit of an overview here of your pass and fails in this chart here. You can also see how it's performing through this AppDex, and I'll show you how that relates to your tests. You've also got some detailed overview statistics that come through. In this case, it's representing all of those scales that we test and showing how many samples were able to be sent through, how many of those were failed, as well as the actual response times that were coming through. And these are all in milliseconds. So you can see here the average response time for all of these tests is 32 seconds. So this actual service is performing pretty poorly. So that's showing how long on average, your users are waiting for your service to be returned and shown. On the end here, you've got your actual throughput, which is the transactions per second. So how many transactions are able to be sent through to your server and how long that takes per second. You've also got a whole host of charts that you're able to go through and assess on how your service is performing. So I've got a couple of different services that have been tested between on the left here, a really good service, and then a service that's reading STE, and then a really bad service that I've set up. As mentioned here is the AppDex results, and what that is, if you click on that, it will open up the Wikipedia page. And I just want to draw your attention here to how that is actually scored. So the closer to 1 you are, the more satisfied your users are, and the closer to 0, the more frustrated they are. And that is all between these threshold settings here that you can set up in your configuration. In this case, anything under half a second is a really good response and what you're expecting. Anything over the 1.5 seconds, your users are starting to become a bit frustrated. This might not be representative of how the map services actually perform. So probably closer on 1.5 seconds for your for this threshold, and maybe around 3 seconds for your frustration threshold. So just straight off the bat, you can see sort of your slower, these are closer to 0, so they're not performing as well. As I scroll down here, we'll see some of the charts responses here, as well as the overview. So in this case, my average is around 6 seconds, which is, it's pretty good, pretty reasonable. This service is around 11 seconds, and then my poor performing one is around 37 seconds. And with this one, I basically set up really advanced labels at all scales and showing really detailed features when I'm zoomed out. Also, if there are any errors that are returned, they are also listed over here that you can go into. Going into some of the charts. Over here, you've got your response times over the actual test run. In this case, I tested for 5 minutes. And here you're getting an overview of how those perform. And you can see here we're looking at sort of around 60 seconds for some of the services, and it's broken down into each of the tests, in this case, each of the scales. Something else to have a look at is your actual active threads that you set up. In this case, I've set a maximum of 30 threads for users, concurrent users. And this will represent the results also, you'll see in some of the other charts. If we go to some of the throughput charts that are returned, you can see here these are pretty much the hits or the requests that are able to be sent through per second. On my really good performing one, I'm almost hitting 4.5 requests per second, and you can see how my poor performing one is really low there. Going down, also looking at the transactions per second. This is really a breakdown of that overview, where it breaks down, in this case, per each of the scales that are tested. And once again, as my thread count increases, so around here was when the threads were at the maximum, around 30, my performance dropped for my my results coming through there. Just a few last ones on the actual response times and reading those. If we have a look at the response time overview, this is now relating back to those thresholds and how each of those services has responded. In this case, 145 are within my acceptable tolerance. This is in between those two settings, and then this is anything over that 1.5 second threshold set. So comparing my good service at 145 good requests being sent through, down to only 24 for this service, and then down to a whole 5 requests on my really poor performing service. If there's any errors also, it will respond and show those in this result. So that's really just showing some of those results and how to analyze the dashboard that's generated in that test. When you're using the command line, you're able to also set up some advanced options for automating some of these tests. In this case, I've set up a configuration file that it's easy to kind of test between different environments. This could be testing between your pre-production and your production environments. Also setting up username and passwords for generating your tokens, as well as any custom configurations that you might want to run. In this case, I'm doing some apply edits on my feature services and testing some web editing capabilities and performance on that. You're also able to automate the generation of your actual bounding box extents. Over here, if my sample points exist or do not exist, I'll go and create those, and just creating that through random points and setting the XY values of my bounding box. If it does exist, then it will just use what's currently there. It's important to set that up so that you are also testing using the same extents, so that you are testing apples with apples each time you run that test, just to make sure that each extent and run is exactly the same. Another option is to automatically update your token, and this is updating that token in my CSV that's then used in the configuration for my test. And yeah, very important for when testing your secure services. Another option is to combine all of your test run results into a single spreadsheet. And in this case, just opening that, I've got 2 different tests here with a few different options. Here you'll notice it's testing exactly the same services and getting different results for that. It's not also about the actual AppDex score. Here you can see my SDE service, according to the AppDex score, is performing worse than my actual bad service. However, when you start looking and analyzing the actual response times, the response time is a lot quicker, and that is purely because of the formula that's used to actually generate this. You need to look at the number of requests actually being sent and the number of failures. So there's a whole formula, and that's explained in that wiki page also. And also in here, I've just added some links to the actual service, so you can open that service as well as open that actual report as a sort of go-to result spreadsheet for that. So a really good starting point is having a look at this blog that was published by Aaron Lopez. It's got a whole lot of links and very useful tips on actually setting up some of these JMeter tests, and a very good sort of step-by-step on what to do for that. Some of the other links are to the other applications mentioned previously. The ArcGIS server logs and statistics, and also the system log parser and the perf tools are accessible through those URLs. And thank you very much. Yes, and with that, I will then hand back over to Zorka.
Thank you, Julian. And what I'd like to talk to you about is what other webinars we have planned. So in April, we have our very technical webinar about detecting cars from imagery using deep learning. In May, we have two webinars. One is ArcGIS for agriculture, and then on 18th of May about WebGIS interconnecting your organization. So these are the ones that are going to come in April and May, but if you want to find other webinars that we are planning for the first half of the year, you can do so from our Eagle website. So now we are coming to question and answer session. So feel free to pose the questions if you haven't done yet. And I'm just putting up the details of our email and contacts if you would like to get in touch, and if you remember some questions later on. So one question that we have for now is about a log parser, and I can take that one. And the question is, what version of server I can use with a system log parser? System log parser supports ArcGIS Server 10.1 and newer, so any of that will be working fine. And there is one question which is kind of a generic. Maybe Julian can find that one, answer that one. What do you think, in your estimate, how long it will take to get efficient in specifying JMeter testing?
Yeah, thanks very much. Yeah, it really depends. There is, if you go through that help or that blog that I showed previously, it has a really good step-by-step on setting that up and which operations and options to use in JMeter. So yeah, setting up that could take a few hours, possibly a day or so, just to get a feel with the interface and how that works. But it's a pretty quick and steep learning curve.
Thank you, Julian. And we'll give you maybe another minute or so if you see if you can come up with any other questions. It seems that we are running out of questions. And with that in mind, I'd like to thank you all for taking time to attend this webinar. If you do come with some questions related to this, please use these details that you see on the screen. Get in touch with us. We'll be more than happy to follow up and answer your questions. And again, thank you very much for attending this webinar, and hope to see you on the next webinar. Thank you and goodbye.